We will now discuss the FLS and EEP modules. We will start with FLS module. So FLS is the flash driver module. So here we'll have the flash driver configuration. So FLS initializes the flash and it performs operations such as read, write, erase to flash memory. So this is basically the use of FLS module. It's used to read, write and perform erases to flash memory. Now it also provides us an interface to set or reset the write erase protection. So if we have these protection mechanisms, right, to prevent write, erase, etc. So this protection can be enabled or disabled using interfaces provided by FLS module. Now the flash areas that we need to actually use from the hardware, even this is configured using FLS. So we select something called as the base address, and then from there we will be calculating the actual flash area that is used. So that's what we are mentioning, that the areas to be used from the hardware is configured using FLS. Now normally the application software resides in ROM, so which is called as the program flash. Okay, so this is where the application code is residing. Now, some types of program flash cannot be written at the same time you execute the code from them. So, when we are executing the code from this program flash, sometimes we might not be able to write values to it at the same time. So, that's the one interesting point to note, that this sometimes this cannot be done. Then the next point is there is something called as data flash, which can be typically accessed at any time. Okay, so the program flash sometimes cannot be accessed, but the data flash is accessible always. Now let's look at some commonly used FLS API. So the first API you need to know is the FLS blank check API. So this API verifies whether a given memory area has been erased but not yet programmed. So it's like a fresh kind of memory. It's not programmed at all. And this way, and it's empty because it has been erased. So this kind of identification can be done using this API called as FLS blank check. The next API we have is the FLS compare. And as the name suggests, it's used to compare the contents of an area of flash memory with that of the application data buffer. So that's what is present in application. We are comparing this area of flash memory with. The next one is FLS set mode. Okay, so it's used to set the flash driver's operating mode. So the flash driver has two operating modes. One is the slow mode and one is the fast mode. Please note that it is not always supporting the fast and slow mode. So sometimes it's is only supporting slow mode. It's not supporting fast mode. So that depends on the whatever underlying architecture we are using. But these are the two modes which we usually get. And in MEMIF mode slow, we read access is like in normal SPI access. But if we use MEMIF mode for fast, then the fast read access happens. That is SPI burst access. So as the name suggests, if you use the fast mode, you will get the faster operation. So that's the use of FLS set mode. This will help us to choose the mode of the flash driver. Another API is the FLS cancel. And FLS cancel is used for canceling an ongoing job. It can be read job, it can be write job, but whatever job that is happening, that can be cancelled using FLS cancel. The next API is FLS get status. And as you can see, it returns the driver state. So what is the current status of the driver? This can be returned using the FLS get status API. Another API is the FLS get job result. It returns the result of the last job. So what was the result of the last job that happened? This can be got using this API. So then there are the common APIs that are used like FLS write, read, etc. But these are peculiar APIs that we should be knowing in additional to the normal read write APIs. So that's why I have discussed them separately here. Okay, then let's move to EEP module. So EEP is the EEPROM driver that we use. and it provides services for reading, writing, erasing to and from an EEPROM memory. Okay, so all these operations, just like in FLS, this is providing all these services. And it also provides a service for comparison of a data block in EEPROM with data block in memory. So this comparison that we saw, like in FLS compare we saw, right? We are able to compare. So such an facility is also provided by EEP module. Now let's look at the APIs that are available in EEP. Again, the normal read-write APIs will be there, but let's look at some more that are of interest. The first one is the EEP set mode, and again it will help us to use the fast mode and slow mode that is available. So slow read access means normal SPI access, and if fast read access means we'll use the SPI burst access, provided we have the support in the hardware. So those can be set using the EEP set mode API. Next one is the EEP compare. So this is the comparison we mentioned. It helps to compare a data block in EEPROM with an EEPROM block in memory. So we are able to compare the data in EEPROM with that is available in the memory. Next is EEP cancel. Again, it's used to cancel a running job. Something is happening, we want to cancel it. That can be done using EEP cancel. Next API is EEP get status, and it returns the EEPROM status. So what is the current status of the EEPROM driver that is got from the EEP get status. Next one is EEP get job result. So this service returns the result of the last job. So what was the result of the last job? This is returned by EEP get job result API. So that is all the essentials you need to know about these two modules, namely FLS and EEP. In the next sessions, we will be looking at the configuration of the memory stack modules. It is there we will be applying whatever we have learned till now.